Hello everyone, welcome back to the Backend Masterclass. In the previous lecture, we have implemented the token maker interface using JWT and PASETO. It provides two methods to create and verify tokens. So today we're going to learn how to use it to implement the login API, where the username and password are provided by the client, and the server will return an access token if those credentials are correct. Okay, let's start. The first step is to add the token maker to our API server. So let's open API server.go file. Here in this server struct, I'm going to add a token maker field of type token.maker interface. Then let's initialize this field inside the server function. First, we have to create a new token maker object. We can choose to use either JWT or PASETO. They implement the same token maker interface. I think PASETO is better, so let's call token.newPASETOMaker. It requires a symmetric key string, so we will need to load this from environment variable. For now, let's just put an empty string here as a placeholder. If the returned error is not nil, we return a nil server and an error saying cannot create token maker. This %w is used to wrap the original error. Okay, so now we have to change the return type of the new server function to include an error as well. Then in this statement to create a server object, we add the token maker object that we've just created. Alright, now let's come back to the symmetric key parameter. I'm going to add a new environment variable to the app.env file. Let's call it token symmetric key. And as we are using PASETO version 2, which uses Chachapoly algorithm, the size of this symmetric key should be exactly 32 bytes. We should also add one more variable to store the validation of the access token. It's a best practice to set this a very short duration. Let's say just 15 minutes for example. Okay, now we have to update our config struct to include the two new variables that we've just added. First, the token symmetric key of type string. We have to specify the map structure tag for it, because Viper uses map structure package to parse the config data. Please refer to the lecture 12 of the course if you don't know how to use Viper. The next field is access token duration of type time.duration. And its map structure tag should be this environment variable's name. As you can see, when the type of a config field is time.duration, we can specify the value in a human readable format like this. Okay, so now we have loaded the secret key and token duration into the config. Let's go back to the server and use them. We have to add a config parameter to the new server function. Then in the token.newPASETOMaker call, we pass in config.token symmetric key. We should also add a config field to the server struct and store it here when initialize the server object. We will use the token duration in this config object later when creating the tokens. At the end of this function, we should return a nil error. And that will be it. However, as we've added a new config parameter to the new server function, some unit tests that we wrote before are broken. So let's fix them. In the main test.go file, I'm going to define the function new test server that will create a new server for test. It takes a testing.t object and a db.store interface as input, and it will return a server object as output. In this function, let's create a new config object, which token symmetric key is util.randomString of 32 characters, and access token duration is 1 minute. Then we create a new server with that config object and the input store interface. Require no errors. And finally return the created server. Now get back to the transfer test.go file. Here instead of new server, we will call new test server and pass in the testing.t object and the mock store. We do the same for the server inside user test.go file, and the server inside account test.go file as well. There are several calls of new server in this file, so we have to change all of them to new test server. Alright, now everything is updated. Let's run the whole API package test. All passed. Excellent. So the tests are now working well with the new server struct. But there's one more place we need to update. That's the main entry point of our server. Here in this main function, we have to add config to the api.newServer call. And this call will return a server and an error. If error is not nil, we just write a fatal log saying cannot create server. Just like that, and we're done. Now it's time to build the login user API. Let's open the user.go file. The login API's request payload must contain the username and password, which is very similar to this create user request. So I'm going to copy this struct and paste it to the end of this file. Let's change the struct name to login user request and remove the full name and email fields. Just keep the username and password fields. Next, let's define the login user response struct. The most important field that should be returned to the client is access token string. This is a token that we will create using the token maker interface. Beside the access token, we might also want to return some information of the login user, just like the one we returned in the create user API. So to make this struct reusable, I'm going to change its name to user response. It will be the type of the user field in this login user response struct. Then let's copy this user response object from the create user handler and define a new user response function at the top. The role of this function is to convert the input db.user object into user response. The reason we do that is because there's a sensitive data inside the db.user struct, which is a hash password that we don't want to expose to the client. Okay, so now in the create user handler, we can just call the new user response function to create the response object. This function will be useful for our new login user handler as well. Alright, now let's add a new method to the server struct, login user. Similar as in other API handler, this function will take a gin.context object as input. Inside, we declare a request object of type login user request. And we call the context.shootByJSON function with a pointer to that request object. This will bind all the input parameters of the API into the request object. If error is not nil, we send a response with status 400 bad request to the client, together with the error response body to explain why it failed. If there's no error, we will find the user from the database by calling server.store.getUser with the context and request.username. If the error returned by this call is not nil, then there are two possible cases. The first case is when the username doesn't exist, which means error equals to SQL.error no rows. In this case, we send a response with status 404 not found to the client and return immediately. The second case is an unexpected error occurs when talking to the database. In this case, we send a 500 internal server error status to the client and also return right away. If everything goes well and no errors occur, we will have to check if the password provided by the client is correct or not. So we call util.checkPassword with the input request.password and user.hashPassword. If this function returns a not nil error, then it means the provided password is incorrect. We will send a response with status 401 unauthorized to the client and return. Only when the password is correct, then we will create a new access token for this user. Let's call server.tokenmaker.createToken, pass in user.username, and server.config.accessTokenDuration as input arguments. If an unexpected error occurs, we just return internal server error status code. Otherwise, we will build the login user response object, where access token is the created access token, and user is new user response user. Then we send this response to the client with a 200 OK status code. And that's basically it. The login user handler function is completed. The next step is to add a new API endpoint to the server that will route the login request to this handler. I'm going to put it next to the create user root. So router.post. The path should be /users/login. And the handler function is server.loginuser. And we're done. However, this new server function is getting quite long now, which makes it harder to read. So I'm going to split this routing part into a separate method of the server struct. Let's call it setupRouter. Then paste in all the routing code. We should move the GenRouter variable here as well. And at the end, we should save this router to the server.router field. Then all we have to do in the new server function is to call server.setupRouter. And now we've really completed the login user API's implementation. It's pretty easy and straightforward, isn't it? Let's run the server and send some requests to see how it goes. As you can see here, the login user API is up and running. Now I'm going to open Postman, create a new request and set its method to post. The URL should be http localhost 8080/users/login. Then select body, raw, and JSON format. The JSON body will have two fields, username and password. So let's look up some usernames from the database in Table Plus. Here we have 4 users that we already created in the previous lectures. I'm going to use the first user with username Kwang1 and the password is secret. Okay, let's send this request. Voila, it's successful. We've got the PASETO version 2 local access token here and all the information of the login user in this object. So it worked. Let's try login with an invalid password, XYZ. Send the request. Now we've got 400 bad requests because the password we sent was too short. We have a validation rule for the password field to have at least 6 characters. So let's change this value to XYZ123 and send the request again. This time we've got 401 unauthorized status code. And the error is hash password is not the hash of the given password. Or in other words, the provided password is incorrect. Now let's try the case when username doesn't exist. I'm going to change the username to Kwang10 and send the request again. This time we've got a 404 not found status code. That's exactly what we expected. So the login user API is working very well. Before we finish, I'm going to show you how easy it is to change the token types. Right now we are using PASETO, but since it implements the same token maker interface with JWT, it would be super easy if we want to switch to JWT. All we have to do is just change this token.new PASETO maker call to token.new JWT maker. That's it. Let's restart the server. Then go back to Postman and send the login request one more time. As you can see, the request is successful. And now the access token looks different because it's a JWT token, not a PASETO token as before. Okay, now as we've confirmed that it worked, I'm going to revert the token type to PASETO because it's better than JWT in my opinion. And that wraps up this lecture about implementing login user API in Go. I hope you find it useful. Thanks a lot for watching and see you soon in the next one.